we are really fortunate today to have Dr. Justin Bowie. He's a freshly mined PhD student and is wickedly bright. And we just did a podcast together, didn't we, Justin? It's coming up Thursday on Mind Matters. And
yes,
we talk about some of these things and other things, but he's going to talk to us today about things which are available on the web. Now, if you are a dedicated, I don't know, how should we say it, computer scientist, there's some people that know the web so well, like Justin. There's others that just learn one piece at a time. And I'm one of those others. So I'm really looking forward to this talk because there's lots of resources concerning artificial intelligence, which is on the web. And he's going to share that with us. So I'm going to turn it over to Dr. Bowie now. Justin.
thanks, Dr. Marks. Hi, everyone. So my name's Justin. Like Dr. Marks said, I'm newly minted PhD. I defended 3 weeks ago. Finally wrapping things up and getting stuff together. But I was asked to talk today a little bit about some of the resources. And before I dive into things, I just quick virtual poll. You can raise your hand or nod or something. But how many of you all are familiar with like Google Colab? And a couple people. Okay. So all right, start super simple. PyTorch, TensorFlow, Caffe, Keras. Yep. How many of you have heard of CoPilot? All right, so I'll share my screen here. We'll start with a presentation, which I know is super exciting, but we'll go ahead and we'll start with that. And then we'll actually do some live coding using CoPilot just as kind of like a cool show, but also we'll throw stuff on Colab and we'll explore Kaggle and just kind of show what type of resources are out there for free. We'll talk a little bit about some of the paid resources, which is a little bit more common in industry when you get out and people kind of inquire, hey, do you guys use Docker? Are you familiar with Kubernetes? Stuff like that. We'll talk about them, but I'll keep it short and sweet, very high level, but I encourage you all to take a look at some of this stuff when you have some spare time and if you are curious. So that was my long-winded introduction. We'll start with kind of just some basic development resources, kind of talk about the common products that are out there, what a lot of people are interested in using, what a lot of people use. Talk about some of the open source libraries, detail, just again, recap. We'll talk about some of the online platforms, what are Jupyter notebooks, who allows you to host and run Jupyter notebooks, competition, some of the open source data sets that are out there and the competitions that go along with them. And then we'll dive right into kind of a real-time programming example. And then at the end of this PowerPoint, which I'll share with Dr. Marks to share with all of you, there's some links to some more reading and just some more of the resources in general. So, at its core, when you're dealing with AI and ML, pretty much everybody starts local system. And so how you go about doing that obviously differs from person to person and preference to preference, but at its core, you've got your package managers, your stuff like Homebrew if you're an Apple user, Anaconda works across Unix, Windows, and Mac OS, pretty popular, but they're just tools to allow you to manage environments for producing software and running code. And it allows you to work with different dependencies. So if you have, say, for example, NumPy or Pandas that requires, version 1.19 or, 0.08, you can run an environment with that, but also have another environment set up for a different program or different package that uses different dependencies. So starting to use them, if you haven't used them before, I actually only really recently started to use them, but they're pretty useful. And then, of course, your IDE, what you like to write in. Some people do all of their work in Jupyter notebooks, very exploratory, which is great, super flexible, not very production friendly. I myself use PyCharm. Anybody else use PyCharm? Okay, as a student, you can get it for free. It's fantastic, and I highly recommend it. A lot of people just use Visual Studio Code. Out of curiosity, who uses Visual Studio Code? Okay, yeah, a couple people. Visual Studios, I mean, it's free. It's, technically PyCharm, there's a free version, but the professional version you have to pay for, but as students, we get it for free. So again, I encourage you to look at it. And then there's code storage, right? When you're working on small personal projects, most people probably don't worry about putting stuff up on GitHub. So again, quick poll, who has a GitHub, who uses it? I strongly encourage you guys to use it. Just if anything, to build a portfolio for when you get closer to graduation. It's something that a lot of potential employers are looking at. So encourage you to use it, look into it. Again, as a student, you can get it for free. So I strongly encourage you all to use some of those free student resources, because in the real world, they get very expensive. So you've got a local system set up, pretty straightforward, but it's pretty limited, right? So you start considering doing some deployed learning, using the cloud to train, like I know last week, I believe you learned about GANs and saw some of their training times. Obviously, you're not going to leave your computer running for 20 some straight days just training a complex neural network, right? You're going to throw that out into the cloud, usually distributed across multiple servers. A lot of the systems out there, both TensorFlow and PyTorch, allow you to do distributed learning. So if you're going through something like Google Cloud or AWS or Azure, you can do a number of different instances in parallel. You can do CPU training, GPU training, TPU training if you're using TensorFlow and specifically Google stuff. I believe they're the only ones that have TPUs available. And then of course you got your memory and storage concerns. Do I have enough RAM to load my data set entirely, or do I have to do batch loading? Obviously, when you get to these more complex data sets, more complex data structures, you're dealing with batch loading, so you're not pulling all of your data set in at once. Really, in the AI space, your complexity scales quite quickly. It's great to do initial proof of concepts on your local machine, but in terms of practical functionality, you're pretty much going to do everything on some type of cloud-based or server-based system. And there's a lot of good resources out there to learn how to do some of that. But all of them have their own quirks, and pretty much every one of the major players, Google, Microsoft, Amazon, their ecosystems so in depth that they all have individual certifications, and they really aren't necessarily transferable in terms of quick and easy to set up. So it's almost like learning a new system in a new language anytime you go anywhere. So you should only commit to one when you're absolutely sure that's what you want to use.
By the way, Justin, you don't mind if people interrupt you if they have questions, right?
Not at all. No,
okay.
Please go ahead. Wave, grab my attention, because I can keep talking and rambling. So if you have questions, just chime in. Open source libraries, I'm sure most, if not all of these, are familiar to all of you to some capacity. Again, the big frameworks right now, and pretty much throughout all of industry, it's TensorFlow or PyTorch. It's kind of like the old Apple versus Windows debate. It comes down to personal preference. Yeah, there's a few nuances, a few niceties that one has that the other doesn't. They kind of stem from different backgrounds. PyTorch has been traditionally more academic. TensorFlow has kind of always been a little bit more industry focused, but as you followed the evolution of the programs, they've kind of come together towards an almost exchangeable nature. And there's a couple of groups out there. Carnegie Mellon, for example, is working on a platform called Juneberry, which is actually going to be backend agnostic. They're designing it with the intent of having industry and science labs and academic labs be able to just define a neural network, maybe set up some parameters, and it takes care of everything else.
Could you define backend agnostic?
It doesn't really care what system you choose. You say, hey, I want a neural network. It's X layers deep. It has, convolution layers in the top. It has dense layers or sparse layers further down. It's got pooling layers or whatever. You kind of give it this generic skeleton, And then you can say whether you want it to be defined in one or the other, or you can just let it kind of self-define. What they're doing is really trying to make this platform universal, so that you don't have this holy war. Oh, I'm pro TensorFlow. Oh, I'm pro PyTorch. It gets more to focusing on model development and less on writing some of the superfluous stuff.
And who are the
those are the big ones.
Who are the companies behind these?
So PyTorch is Facebook, and TensorFlow is Google. A lot of the open source platform, a lot of the open source libraries, like OpenCV, Pandas, and stuff like that, I believe they're mostly community driven. They have sometimes some organizations that have formed around this, supporting them and developing them. But all of these resources, because they're open source and they're free to use. So it gets very interesting to see how often some of these updates are pushed. TensorFlow right now is on 2.6. PyTorch is on version 1.9. And Dr. Marks, when we started our research together, it was TensorFlow 2.0 was in beta, and PyTorch was on 0.9. So they come out with a pretty significant release on average about once every 2 to 3 months. And in those new releases, they'll obsolete some of the older practices, some of the neural network definitions or less efficient function calls, and they'll add new features. So one of them that, if any of you happen to attend my dissertation discussion, structural similarity came up as a conversation. So that's one of the things that TensorFlow recently implemented into its image API. So these tools are constantly evolving, which is great, because you're not like in a traditional software environment, you're not paying for a new update or a new license. The hard part sometimes is actually just keeping up with all the changes, and making sure that some of your older models don't break. They do a pretty good job of maintaining that backwards compatibility, but I know when they made the transition from TensorFlow 1 to TensorFlow 2, you basically were starting over. It's not quite been that bad with PyTorch. PyTorch is a little bit more Pythonic in nature, so it tends to be a little bit more true to both the coding style of Python, but also just generally maintaining that backwards compatibility. But since TensorFlow 2 has been out, most everything has been backwards compatible, barring any depreciation of functions. But there's a lot of resources out there.
Justin, Google and Facebook, what would motivate them to give away free software? What's in it for them? This is it's a little bit off topic, but
that's a good question. It's I think part of it comes down to allowing people to get access to some of these resources, right? If you had to write your own machine learning library from scratch, you're talking about even getting down to the calculations for forward and back propagation, most everybody wouldn't be playing in the AI space. I think part of it becomes almost a marketing campaign of sorts. It's almost free advertising, right? All these companies out there today are like, oh, we're using AI, we're doing stock market prediction, or we're doing image classification and recognition. It becomes a way, oh, hey, they're using, they're doing AI. I think a lot of these developments would be more severely constrained had they not open sourced a lot of these tools. And I think there's, in general, at least I've noticed in software, there's a general push towards open source stuff to begin with. It shifts the burden away from technical debt of a company into and more to finding a niche problem to solve, right? You no longer have to worry about, oh, I have to solve a problem and develop the tools to do it. Now I just have to focus on solving the problem. So I think there's some of that. And then of course, there's always the, they want you to use their cloud services approach, right? Google offering Google Cloud hosting for virtual environments and stuff. Yeah, I can train a reinforcement learning algorithm on my computer, and it might take about 20 hours, or I could throw it on GCP and it can be done in about 40 minutes. It may cost me $5, but might not be bad to have my computer for 19 hours and really 20 hours to be able to do some other stuff. So I think that also kind of plays into why you would release it for free.
That also is something that really interested me, that not only is the software available, but free computational resources are available. That's really very generous of them for some reason.
Again, it kind of ties into that free advertising thing. You do notice that AWS doesn't exactly have a free tier. They do, but it's very buried in the weeds and it's pretty limited in terms of what it can do. Basically, they give you a free virtual Unix machine to do whatever you want with, up to a certain number of hours, certain number of run hours. Now, AWS powers a significant portion.
What is
Amazon Web Services?
Amazon, thank you.
Yeah, they power a boatload of stuff, and they have some really, really interesting libraries out there. They have Recognition, spelled with a K. That's their like generic image processing and classification library. I've gotten the chance to tinker with it a little bit. It's not free, so I don't recommend any of you trying to do unless you want to fork over a little bit of money. But it's actually pretty impressive, right? You can take a picture of it and it'll identify all sorts of objects in the picture with very high accuracy.
So the question is fork over a little money. How much? $5, $100, $1,000?
It's probably about $5. Yeah,
Okay.
What I did, I was consulting with a company, and they wanted to do some image processing, and they gave me some money to do it. So I don't actually know how much it was, but it comes down to like runtime in seconds. They bill you by like the runtime. And if any of you ever happen to take the AWS training, they talk about their costing breakdown and how you, I guess, because part of being a solutions architect or whatever they call their certified people. Part of that is understanding the pricing model so that when you talk to clients, you can kind of give them a rough feel of like, hey, running something like this may cost you, $1,500, $2,000, $2,500 a month versus running something like this may cost you $50,000 a month. I think that was the thought process behind it. But they do this pay as you go type model. So it for an academic exercise, right? It's really hard to sit there and be like, well, how much would it cost me to train this model? When you look at some of the big models like GPT-3, something that's trained for 40, 50 days on multiple systems, the bill to train it's in the millions. So, that's something that when you look at practical systems, not everybody's going to sit there and train $1 million, $2 million network, but maybe a handful of times a year, depending on your use. But when you look at all those models, if you were to distill them down, they're basically built out of these libraries. Most people, it just comes down to personal preference, what you want to do, what you want to work with, how you want to work, and what you learn first. I learned TensorFlow first, and so that's what I'm more comfortable with. But I've done some work with PyTorch too, and I find PyTorch to be easier to use with reinforcement learning and like GANs. I find TensorFlow much easier to work with like more traditional classification type networks. But that's my comfort level. Obviously, depending on what tools you all use and what you've kind of learned and feel comfortable with, you may differ. The online platforms, we talked a little bit about this already, but Jupyter Notebook resources, for those of you that aren't familiar with Jupyter Notebooks, it's basically just kind of like an embedded browser type of IDE/runtime that lets you run code. The big ones, at least the ones that I'm most familiar with, Google Colab, which is what I did almost all of my PhD research in, with the exception of one notebook that ran on Kaggle's system. And then Datalore is a tool that's made by JetBrains, the same company that makes PyCharm. I have not actually explored too much of that. So that's if you want to use a Jupyter Notebook style. Jupyter Labs also recently released an IDE/a notebook runtime, but I've not yet tried it out. I don't know if anybody else has, but if you search up Jupyter Lab, they also have one. But again, talking about or discussing what we were talking about a little bit previously, most of these systems end up running on virtual machines. So if you want to build and deploy a pretty widespread model, you're going to go with something like an Azure, an AWS, a Google Cloud implementation. You'll spin up some virtual machines. and you'll let your model train, or you'll deploy your model and let it run at time. And that's how most people do it now. Some companies have custom backends. I know IBM has some resources and stuff too, but almost everything I've seen lately is coming off of AWS, GCP, or Azure.
Justin, for newbies, do most of these sites have tutorials that let you
Yes.
ease into the water?
Mm-hmm.
And are they good tutorials in your experience?
Some are good, some aren't. If you just go to Google Colab, they have some pretty good introductory tutorials, both how to use Jupyter notebooks and also how to do they have some examples of machine learning. Kaggle actually offers courses. And when we go and we explore Kaggle's website, I'll kind of show you where some of them pop up, but they actually have like mini courses where they'll teach you like the basics of regression or classification. And they're pretty good step throughs. They assume you have a comfortable level of programming knowledge. So at least from a logic perspective, it doesn't look foreign to you, just some of the techniques are new. But there's a number of both free and paid resources. There's stuff like Udacity, Udemy, Coursera. There's a lot of online platforms that'll offer basically like mini college semesters for anywhere from like $9.99 to like, I guess they get up into the hundreds for courses. But you can take stuff from like Andrew Ng, Jan LeCun. They have some classes on like Coursera. There's a couple of some of the earlier Amazon machine learning and Google machine learning engineers that have classes on Udemy and stuff. So if you're curious and want to learn a little bit more, they typically will focus on a particular area. They'll focus on a particular area like classification, like convolutional neural networks and stuff like that. But they are good resources. They only get you so far. I found that they're a great place to get started, but most of the time just tinkering around and trying new things teaches you just as much. But there's some level of comfort, I think, that has to be achieved before you can really start there. Data sets, another big thing, is easy access to data to work with. So TensorFlow has built-in data sets. PyTorch also has built-in data sets. They're really good for the hello world type of introductory problems. You've got MNIST, fashion MNIST, a couple of variations on these small NIST standardized images. They've got color images, cats versus dogs, all kinds of different things. Kaggle is a platform that allows companies and individuals to actually host challenges. So their data set catalog is actually quite extensive, because typically what they'll do is when they've hosted a competition, once the competition is complete, they'll just open the data to anyone. As long as you want to go in and grab it, you have access to it. Microsoft has some of their data sets posted through Azure. And then there's a couple competition specific sites like data.world that have data sets similar to what Kaggle has. But that's kind of, one of the machine learning engineers' banes, right, is getting enough data to be able to work with and train. I think it's one of the most underappreciated challenges when it comes to developing and deploying systems, is making sure you have enough data, and not only enough data, but enough good data. And so these data sets, they really provide a good starting point. A lot of people will take some of the stuff developed with them and then use transfer learning to approach other problems. And so they don't have to constantly reinvent the wheel. They may be, changing out the nuts or bolts or whatever it may be. Competitions. This is something that I think is somewhat interesting. They throw money prizes out there. Kaggle specifically, AI Crowd has a couple, but there's cash prizes. There are at least 2 challenges on Kaggle right now with prize packages in excess of $100,000. Split out. It's split across 10 or 20 teams, depending on how the competition is structured. But you can make some really good money working on these. A lot of international teams will compete. You see a lot of teams out of China on a lot of the competitions score really well traditionally, and they all seem to be AI related professionals. But it's open to anybody. Anybody can jump in. Stuff like Numerai. I don't know if anybody's heard of that. That is a what's a good way to describe it? It's a open competition for predicting stock market performance. It's a little bit different from some of these other ones because you stake money. So it's a little bit of a gamble in the sense that you bet on how well your model performs. But they have something like, I was looking at it yesterday, and they're like $9.5 million or somewhere $9.8 million is like their most recent. They go like month by month, and it's based on monthly performance that they split. But you gain. It's a crypto coin. I think it's tied to Ethereum, but they kind of created their own coin to reward people with based on their network's performance. But the interesting thing is you could lose money. So if your model just performs terribly, you could reasonably lose all the money you invest into it. But I guess they're getting some really interesting financial forecasting networks to come out of there.
Yeah, if it's a stock market, it isn't gambling, right?
Yeah, sure.
Okay.
Yeah. But yeah, there's a number of them out there. Again, if you guys are all curious, my recommendation would be start with Kaggle. They tend to have the most approachable ones. And there's a lot of good resources. A lot of people will open source their code. If say they're in the competition, they're just not performing well, they'll open their notebooks up and you can take a look at it. You can copy it like outright. There's an option to straight up copy the notebook. You can make notebooks private. Of course, if you're competing, you don't necessarily want to let everybody see what you're doing. But I find it very interesting because some of the techniques that people use to solve these problems, I would have never thought of. So I at least find it a fun learning exercise to see how people approach problems differently. And so yeah, we'll explore a little bit of Kaggle here in a few minutes, but let's see here. All right, so before I jump to the links, so GitHub's CoPilot is an AI-based programming assistance tool.
By the way, is there anybody that doesn't know what GitHub is? Well, who knows what GitHub is? Okay, why don't you just talk just a little bit about GitHub, because
sure. So
I think everybody doesn't know it.
GitHub is a code repo website bought by Microsoft a number of years ago now.
Okay, and what's repo?
A repository. It's a place to store code. They've been working with OpenAI and some of the Azure dev team to develop an AI assistant for programming. So the goal is to make programming more accessible to everybody. And the way they've done it is actually quite interesting. They've trained it on something like it's trillions of lines of code across multiple programming languages. And so what I wanted to start with, because I think it's really cool, at least, is just a quick demo of that. And then we'll take this and we'll throw it on Colab and kind of see how Colab works. But the way they've done CoPilot is interesting, because what you can do is you can basically type out comments. So I'm going to use Python. That's my programming language of choice. But you can basically say something like import TensorFlow, matplotlib. And you see how it starts to.
No, we're
Justin, not. I think you're only sharing your PowerPoint window.
Oh no!
Yes.
Well, that's disappointing. Let me delete this line of code. So it's really exciting. Okay, can you guys see my IDE now? Sorry, yes. I thought I shared the whole screen. That was my bad. So this is a line of comment, right? I want to import my libraries. So you see it popped up with a suggestion: import TensorFlow STF. You can tab to complete, import matplotlib, import NumPy. All right. So basically, this one's not quite as impressive, right? This part right here, but for someone who might be new to programming, if you comment out what you want to do as you go, part of what CoPilot does is make recommendations, right? So first step, let's see, let's load a data set. So let's, what do you guys think? We want to do fashion MNIST? Anyone have a preference?
Sounds great.
Okay. All right. Load the MNIST data set. So it comes up with a suggestion. If I don't like that suggestion, I can look at all of these other generated. I'm going to drop the thing. So these are all of these solutions that CoPilot generates based on training, which is really interesting because I'm going to use the Keras datasets one, right?
Just to be clear, what program are you using here?
This is Visual Studio Code.
Visual Studio, thank you.
Yep, and CoPilot is open source. Right now, it's in beta, so you have to apply to get permissions. I only just got permissions on, I think, Thursday of last week. But I think it's pretty cool. Glauco and I were having a conversation about, like, how good is this thing at work? How good does this thing work, right? Reshape the data, right? So basically, I haven't really typed actual line of code yet, and we've already loaded our data set and done a little bit of pre-processing. So when I was going through and doing my some of the code for my dissertation, it would have been really nice to have this, because I can't tell you how many times I screwed up the image reshaping and all of that. So it's kind of nice, right? But like, I mean, at this point now, it's going off and it's doing whatever it wants to do, and great. So there's a one layer convolution neural network. That's it's file, then let's see, train. Yeah, so it's very interesting, right? So this is kind of one of the directions that AI is heading, right? They're making these tools more and more readily available, this is something that I believe some of the Microsoft team has been using now for the better part of a year, and I think part of it is understanding when you have these sorts of tools what you can do, right? I mean, this tool, as far as I know, is going to remain free, right? And so if you can have engineers being focused on novel model design and not have to worry about a lot of the pipelining, you start to think about, okay, well, where can we take this, what are the limits? Where do things become impractical, right? This is a super simple example. This is a really basic data set, but and a really simple model, but it kind of works. Here, where is, I'm going to share my whole screen. We throw it up on Colab, right? Let's just see if this thing actually works and how well it works. Right. So when you open Colab, typically this is the first page you get. So my default account doesn't actually have any notebooks. These are the tutorials, Dr. Marks, I mentioned a little bit earlier. The first time you load up Colab, this is what pops up. A couple examples of work that can be done, right? So here's the Detectron 2, right? So common open source model people use, right? So it gives you this whole spiel about what it is. It lets you do markup language, so you can add notes and comments just as you would. It's one of the benefits of Jupyter Notebooks is you can do this combination of markup language and code in the same thing. So you can almost write, in a sense, a textbook. In fact, I think some people are working on writing a textbook using Jupyter Notebooks. But it's really cool. because I don't need to worry about setting up my local environment, worrying about managing my packages and stuff like that. See, that's an old one. It's connected. You load it up, put your code on there, you hit play, and this is it, right? So this is running on a CPU instance on one of Google's servers. And this is the freeware version, right? So there of course are some limitations. You can use GPUs for a certain number of hours a week. You're limited to slower GPUs, which still make it incredibly fast, but it's free to use. So, I guess in a sense, beggars can't be choosers. But if you're trying to test something real quick or you're curious about something, you can just fire up Colab and it'll run, right? So this will run for probably about another 3 minutes. So we'll come back and check on that. Kaggle, right? There are a number of different side options here. We talked a little bit about some of those tutorials. That falls under the courses section, right? So they have one in basic Python, introduction to machine learning, a little bit more complex topics, but all these free to use. You click on them. Let's say geospatial analysis, right? So you click on them. They give you a little bit of a small lesson, some example code, and then they'll follow it up with kind of like a small lab, right? So they'll give you a notebook with pre-populated, a couple things missing. You go through. It's a really good, like I said, it's a really good way to maybe get your feet a little bit wet and learn some of the basics. But I assume that, since you guys are all taking this class, you're probably a little bit more familiar with some of the nuances and the details than perhaps somebody who's like, oh, I worked as a plumber for 40 years, but I'm going to do machine learning now. Not to say that they couldn't do it, but the tools and everything, part of making things open source and providing these free resources means that you can get potential employees and workers and contributors that would not have been able to do so otherwise. So it's kind of in a sense a trade-off of disseminating the resources for the sake of perhaps getting more working resources in the future. But we talked a little bit about those competitions, right? So this is a list of some of the more popular active competitions, right? So there's one here that's doing helmet assignments. So the only thing it's doing is identifying and it's identifying and then providing a bounding box around the helmets for every player in an image. So if we dive in here, we can see a little bit more about what it is they're doing. So every competition will come with kind of a brief description, how it's evaluated. So this is a couple, usually they have different evaluation criteria.
Could you go back to that video and tell us what's going on?
The previous one?
Yeah, you mentioned this when we talked last. They're trying to follow helmets, I think it is, right? This is that big competition you were talking about?
Yes.
Because they would like to assess impact and acceleration of the bumps and
yeah. So what they did a few years ago, they put out this grand challenge to do helmet-to-helmet collision detection to help analyze player risk. It turns out that the way they promoted the competition, it was a little bit more than what people could handle and computers could handle at the time. So they've since broken it down into smaller chunks. Last year's was trying to detect individual collisions in like player on player video. So it wasn't whole field type. This year they're giving you a field of players and you have to identify the helmets and then track them, right? So you see those green dots kind of come up every so often that's showing helmet to helmet contact, right? And so part of what the NFL is trying to do is to help make some AI to detect some of these potential concussion contacts, stuff like that, be able to monitor it, understand how often it happens. There's another competition using American football that is looking at developing a new metric to determine special teams performance. I'm a little bit curious to see how this one will go, but this one is they're looking at all the special teams plays, so kickoffs, kick returns, punts, field goals, stuff like that, and then based on outcome, trying to assign a value or a score to the performance.
By the way, I always thought that one of the subjects we cover, which is swarm intelligence, and if you evolve swarm intelligence, I always thought that could be an interesting application to football.
To football, to do
because it is
to replace referees with robots?
No. In terms of offensive and defensive strategy, evolve a good strategy for a good offensive strategy for a known defensive strategy. Anyway, just a thought. I mean, everybody's doing deep learning. We got swarm, we got other stuff.
Yeah, well, there's all sorts of different competitions. You've got some cell segmentation, identification competition. So there's a whole variety of different competitions out there. I think that the interesting part with these is just seeing the different types of data that people work with. Typically, as you dive deeper into your research, you tend to focus on a particular area, and by association, a particular type of data, right? So my research worked around image data because that's just what I started to work with, and we just increased the complexity on the image side. But you could very easily have worked with time series data. You could work with more medical device data, doing stuff with like MRIs, X-rays, stuff like that, where you have an image, but you don't necessarily have to use the image. You use raw data as well.
I'm looking at this and I'm looking at the results. I did some consulting for a company called Neopath that looked at image recognition on pap smears. This was from ladies' cervical smears in order to detect cancerous cells.
Yeah.
And I look at what's happening today. And this company, this was back, in the middle 1990s. They were really on the cutting edge, but it looks like today that problem would be almost a toy problem to what we have today. It's really fascinating how AI is accelerated.
It's grown a lot. I think part of that is there's more people tackling the problems, right? You have a boatload more AI engineers than you did 20 years ago. You have open source resources and tools and access to relatively cheap computation that we didn't necessarily have 15, 20 years ago. You have these much bigger mega systems, right? You have these Google Cloud and AWS systems that, cloud was kind of a thing back then, but certainly not in its current manifestation. And the strange thing, I think, is how radically things have changed. Like even just in the last few years, how much this area has grown. I swear everyone and their mother is talking about using AI in work and our business is different. We use AI. Guess what? Everybody's using AI now.
Everybody uses it.
I don't want claim, right?
I don't want people to miss. Go back to the top there.
Yeah, sorry, I was
previous
checking
screen.
To see if the notebook.
Yeah, $75,000 prize. So that's.
Yeah, and so they have it broken down, right? Top 5 get money. In these competitions, they're months long, right? So it's not something that you're going to produce. And I mean, you may produce some results in a weekend, right? But like, here's an example. This team has entered 30 submissions, right? So they're probably, I think you get 5 a day. So they're probably looking at doing 1 or 2 a day over the last few weeks, right?
You know what it strikes me? Maybe the reason they're giving all away this free AI is they want to get cheap programming. Because
that's part of it, right? So part of these competitions, let's see, that is under, code requirements. Is that under evaluation? There is something in the description that talks about open, like the code becomes open source, right? So when you submit a competition result for evaluation, if you're accepted as a prize winner, more often than not, basically you're giving up the IP rights. So for this host to drop probably about $100,000 in this competition, 75,000 in prize pool, then I think it's like 10 or 15,000 for administrative. They're getting IP, which would be worth and cost a lot more than the competition. So it crowdsources a lot of the challenges that a company would otherwise have to put several million into. So it's very interesting, and it's a great way for younger or more inexperienced engineers in the AI space to sink their teeth into real problems without having to find an AI specific job, right? So it's kind of a win-win in a way, but I'm sure it makes a nightmare for lawyers. So anyways, so quickly jumping back to that code that CoPilot was nice enough to write for us. Let's see, it took about 2.5 minutes to run this whole chunk, and you get a test accuracy of about just under 99%, right? You can do multiple code chunks. So this is some code that was written for our second publication, Dr. Marks, where you can run different chunks at different times. The nice thing is you can connect this up to, and on a GPU, it runs for, there you go. That's how long the training times were. So on the order of, 3-ish minutes per model. On a GPU, it's probably about 18 minutes on a CPU per model. But it's nice because you can fire these up and leave them running for the free version times out after about 40 minutes of inactivity, and I think you're limited to 2 or 4 hours of runtime. That's the caveat to the free resources, is your runtime limited. So not only are you pegged with the slower GPUs, which still aren't that slow, but you're limited in how long you can run. Kaggle, on the other hand, who also is owned by Google, fun fact, they'll let you run for, and let me go to, just as a quick example, so if you go into edit here, if you have a notebook, you see like over here on the right hand side of the page, I've got 36 hours of GPU quota to use for the week. And so it differs a little bit every week. Typically it's between 30 and 40 hours. The nice thing about this is you can set up your network to run, or your notebook to run, and just leave it go. You can share notebooks with like teammates and stuff if a couple of you are tackling a problem. I'm trying to think. I don't believe Kaggle has a premium tier. You can offload stuff to Google Cloud, but then you're paying the Google Cloud fees, and I don't know what those are. I haven't looked into GCP much.
Question, Justin, if you run code on, I don't know, Kaggle or one of these free resources, do they in any way have claim to the code you run on there?
That's a good question. I don't know how. I don't believe they have any claim of ownership, right? Like you're talking about in like a traditional work environment, right? If you do some type of work on the company's asset, the company has legal rights to it, right?
Well, I'm thinking too of the Amazon classic of mining, mining personal information, and I could see where they could give away stuff free, but what do they get? They get a better brand, of course, like you mentioned. I'm always suspicious.
Well, I think that's fair. I do think most of this stuff, I believe you retain the ownership unless you give open source licenses, but like this notebook here, I believe, is made public, and so at that point in time, they assign one of the licenses. I don't know which one. I want to say it's the GNU one, but I don't know 100% for sure. But they'll assign an open source license. If you were intent on having completely secure and privatized code execution, where you weren't, where you were pretty much guaranteed that they wouldn't be snooping, you'd be going with some type of private compute instance, something like an EC2 type, Unix cluster on AWS or on Google Cloud or something. You would basically be paying for resources directly at that point.
Okay, thank you.
Mhm. And that's really all I've got. That was actually a little bit longer than that would be, but I figured, we could open up the floor to questions and discussions and just chat for a little bit, or Dr. Marks, if you have stuff you want to dive into, that's cool too.
Yeah, well, I just wonder if anybody else has any questions. I've been doing most of the alternate talking here. One of the things that I am going to ask you guys to do is to do a project on convolutional neural networks using one or more of these processes, or if you have an alternate project that you would like to do using one of these, make a proposal to me, and I'll be happy to do that. But I think one of the things I'd like you to take away from this course is the knowledge of the existence of these resources, which Dr. Bowie has been very nice to explain, plus a modicum of working knowledge. Okay. And if you're interested in diving deeper in the working knowledge, then again, I would suggest you the class in Electrical and Computer by Dr. Liang Dong, or in Computer Science by Dr. Pedro Rivas, both who teach much more intensive neural network sorts of classes. So any other questions that people have, or any additional information that you might have concerning this? Maybe you've used it and have some experience.
I just have a quick, possibly silly question, but that code you ran on Colab earlier, what exactly was that doing?
Oh yeah, that was just a MNIST digit classifier. Just a super shallow convolutional neural network. So yeah, I'm not sure what all of your comfort levels are and what all you've learned. I know last week Glauco talked to you all about GANs, but GANs can be really intense and they break very easy. In the research that he and I collaborated in, he always did a little bit more of the GAN stuff. So and then I dropped the PowerPoint into the chat. Links are at the bottom. There's a couple different links there. So I figured that way you all have them.
Okay, let's see. Okay, what I'm doing is I'm saving it here.
It's also on our share drive, Dr. Marks.
Oh, is that right? Okay.
Yeah, but I figured that way everybody else could snag it off the Zoom chat.
Okay, that's great. And what I'll do is, where do you have this stored, by the way?
If you dig into the presentations folder.
No, but I mean, this is something in Dropbox that you're.
Yeah.
I see. Okay.
Yeah. So you have access to it, but now everybody else can either pull it from the chat or you can send it out later.
Okay. This is great. Any other additional comments?
I have one. Just in I forget the name of the thing, but it's the AI helper. Was it called CoPilot?
CoPilot.
Okay, great. Is that compatible with whatever IDE/language you would use? Like if it's a common one, or is that IDE specific?
Language, yes. Right now, I think it only works with Visual Studio Code.
Okay.
My hope is that they'll bring it to PyCharm, although I feel like I can still get better at writing software and would like to not use it, if that makes sense.
Right. Yeah.
But I don't know. It is kind of cool. When I used it the other day, it came up with a 3-layer convolutional neural network. So it's like, you type 3 comments and a minute later you have a fully defined network. Now it's a little bit alarming in the same sense, right? Because while I can look at the code and I have some intuition about what's going on, my girlfriend could look at the code and she's computer illiterate and get the exact same results, right? Because all she has to do is hit tab and enter. So, I know that the high level goal, right, is to make a coder out of anyone, right? So you don't need this super detailed level of expertise. But I gotta be honest, I anticipate it creating more harm than good in the short term. You're gonna have a bunch of people put out stuff and then not really know what it's doing, and then it'll break, and then somebody else will have to come along and fix it. But as a novelty, I think it's pretty cool.
Yeah, cool. I have another question about cloud resources. So I remember one you mentioned was Google. Google has some kind of GPU or something or other. Is that like you just type in Google Cloud in the search bar and it's in your web browser type thing? And
If you go to, if you just search if you just search GCP, it's the first one that pops up, but the formal link is console.cloud.google.com.
Okay, and that's fully in the browser. You just upload code from wherever you have it. Okay.
Yep. Or a lot of times they'll do virtual machines. You just SSH in.
Okay.
Very similar to how you all would use Kodiak if you guys use Kodiak. I could never quite get it to work, but I'm not really on campus, so I don't. I go through a couple extra hoops.
Yeah, I was actually I got it. I'm actually training a model right now on Kodiak. So if you all have any questions, I can do my best to answer them.
Yeah, would you elaborate on that? I know Glauco uses Kodiak, but that Kodiak is, as you know, is a bear, and therefore it's the Baylor kind of supercomputer, I guess. Could you, Colin, could you talk about that a little bit? That availability for students?
Yeah. So I don't know like how access credentials are distributed, but I think like if you email like your advisor or Pat Heinen or Brian, one of those folks can get you access to it. But if you have access, I think Kodiak has like this module system where you basically define a shell script, and then that shell script will run, you know, the Python script that has your model in it. So, you know, if you define a TensorFlow model or a PyTorch model, I've only been able to run TensorFlow models on there. I haven't experimented with PyTorch much.
Do they have PyTorch installed? I don't remember them having PyTorch, but I also haven't tried to use.
I do know that Glauco had Tensor on Kodiak.
Yeah, he had TensorFlow.
Yeah.
Yeah, I'm hoping one of these days they'll actually get something working so you can just push a Docker image onto Kodiak.
Yeah, that was actually one of the things I was going to mention next. Was just out of curiosity, who's familiar with Docker?
First of all, what is Docker?
It's a containerization software. Who's familiar with containers? Obviously, besides Colin. Okay, no worries. They're not. It's not really something that you learn about unless you were in industry. I've used it once. It's basically a way to create an image that contains all the modules, all the software, everything that you need, and then you can deploy that image to a compute instance. So one of the things that as you all kind of explore the space, you'll hear a lot about is Kubernetes, Docker, or containers. They're really common. Kubernetes is essentially a library that lets you organize multiple containers at the same time. And this stuff, I've tried to learn up a little bit on it because everybody seems to want to be using it, but it gets into the weeds really quickly. Basically kind of what Colin was alluding to is hopefully Kodiak will let you push a Docker image and then just run the Docker image. Right now, Colin, correct me if I'm wrong, but you basically set up a shell script that has all of these commands, train the model, evaluate the model. You have this like extended script and tells you what files to pull from. A Docker image would basically take all of that into a single Docker file, and then it would have all of the components loaded and execute based on how you wrote your code normally.
Yeah, another thing that's great about Docker is if any of you have like an NVIDIA GPU in your laptop, or maybe you have a workstation at your dormitory or house, it's really a pain updating and installing NVIDIA drivers. So one thing you can do is just pull down the Docker image that has all of those drivers installed, and you can basically just run your model instantly. So like that's what I do for all the models that I train at home, is I just pull down the latest TensorFlow image or a Docker.
Oh, so you use Docker for that? Nice.
Yeah, there's a little bit of a learning curve to it, but it's very rewarding if you take the time to get familiar with it.
Yeah, if you guys have the opportunity and have a little bit of time to be willing to pick it up, I do recommend it as well. It's something that a lot of people are interested in, just because, like I said, if you can build up a container, you can deploy it across multiple systems very quickly. And so when it comes time to looking at productionization of models and stuff, it's pretty much going to be containerized. So it's worth learning.
Okay, yeah, go ahead, Matthew.
Just a question on computing resources. You mentioned it briefly, like you could run something on your computer, on your home computer. It's going to take 20 hours. What if, like, I had a VMware virtual machine or an Oracle Box virtual machine, and gave it like 8 gigs of RAM? When I have to pass in my GPU, like, what times would that be looking at? Would that be 20 hours, 2 days, or?
It depends on the complexity of your model.
Mm-hmm.
Excuse me. One of the if you were going to do something like a VM, I would recommend doing like a separate, like almost like desktop station with dedicated GPUs,
Mm-hmm.
and then pushing stuff to train that way. In my experience with using local hardware, now I don't have a super fancy desktop that's designed for this kind of stuff. I know a couple friends that have built theirs, but they've cost a lot of money. But models can take, a couple hours to run. It's not a big deal. A couple hours is not bad. You could set it up to run overnight. And the nice thing is it won't time out. You won't lose it. But when you talk about looking at some of these more complex things like training a GAN or doing much larger resolution image classification, it's going to take on the orders of magnitude higher, right? Because you're just, the amount of data you have to work with per image is much larger. Your convolutional calculations are much longer. It's just, it's the economies of scale in the opposite direction, right? You're adding a whole bunch more, well, all of a sudden it costs a whole lot more time to be able to do that. That's really where these cloud resources come into play, right? You can configure, if you write your code correctly and execute it properly, you can load it onto a TPU, which is basically an ASIC that's designed to do tensor-based calculations, and it can rip through a lot of stuff very quickly. You can train models in under a day that would take a GPU 2 to 3 days and a CPU several weeks. But there's some extra upfront setup and configuration you have to do, and then of course you have to have the resources available. But from my experience, if you all are working with anything beyond something like an MNIST or a CFAR, try to use an online resource. It's kind of the direction everything's going, so it gets you that experience, but also B, it doesn't sync your local machine or one of your local machines to being a dedicated run engine. But if you're doing something smaller, like you're doing 1 or 2 epics, something that you just want to test real quick before you go and invest all that training time, then that's totally reasonable. But just bear in mind, if you're dealing with something on the larger scale, that it may even still take an hour or 2 to get to that point. And usually like 1 training epic doesn't do you much good. 2 to 3 is probably enough to say, hey, did this idea work, or is this complete garbage? But a lot of models, most of the tutorials you'll find will run something for about 20, 25, and they'll implement early stopping. And so you'll see something between 15 and 25 epics usually. And then at that point, you're kind of just wiggling in noise in terms of performance improvements versus overfitting. But I've seen models that have been trained for several thousand epics. If anyone's familiar with reinforcement learning, you're training over hundreds of thousands of epics or more, because you need to give it the chance to run through a whole bunch of different opportunities and a whole bunch of different environmental situations. And so, when you talk about really long-term training, RL models, I've seen RL models that have been trained for 43 days, 45 days on GPUs to make 4 stick figures play soccer. It's really cool that they can do that, but then I look at the computer, the computational costs. I'm like, wow, that's maybe it wasn't worth it.
No, Sam did that. Sam had soccer players using swarm intelligence, so It was, but it was totally heuristic. Nothing was learned.
Well, I do think that there's going to be some combination of they do now what's called imitation learning, where they'll basically watch somebody play, record the actions, and use that to base train, and then let them do the exploration. So you get this combination of they have some baseline established level of play that they then can deviate from, and that does cut down on some of the time, especially because the initial trainings, it ends up being pretty close to garbage, right? Because you have these totally random actions that don't have any logic. It's like going back to the chess example, right? The Kaspersky chess example where they made that super move, right? And it turns out it was just a bug, but pure chance, right? Had to make a move.
Have you guys heard about that? Kasparov was playing Deep Blue, and Deep Blue made this incredible move. And some of the chess commentators said, this is brilliant. It's both defensive and offensive. And Kasparov was psychologically thrown off his game. He says, oh my gosh, I have no idea why it did this. And then a few decades later, one of the programmers of Deep Blue said, our computer didn't know what to do, so it just chose a move at random. So it was just totally off, but it did throw Kasparov psychologically off his game, and he lost. So who knows?
But well, and the nice thing is there's a lot of different avenues to explore, right? Some of the resources that I mentioned that really kind of only scratches the surface. Just if you wanted to explore the Kaggle data sets or like jump into something like AI Crowd and look at some of the data that they have, there's enough to keep you busy for weeks.
One of the things I hope you would comment, we talked about this when we talked previously, but is the future of AGI. This is artificial general intelligence. We talked about this in the class when the course began. But you made some interesting observations looking at Kaggle and some of these other places that kind of, we're not getting this AGI, this artificial general intelligence, which purports to duplicate what people do.
Right. Yeah. No, I kind of stand more and more firm behind the highly specified development and use of AI. I just, in a lot of the stuff, a lot of the competitions that I've observed, and a lot of the open source code that I've reviewed, it's very application specific. And I know people will shout, oh, well, you can use transfer learning. It's great, but part of using transfer learning is you forget what you transferred from. And so it begs this question of, how many different models am I willing to use to get this general intelligence, right? So I think what we will see is what people classify as AGI, Lovelace test independent. Something that can do a whole bunch of different things is actually just going to be a whole bunch of different submodules all strung together with some high level, pipeline, right? Oh, I'm working with image data. Great. These 45 models that deal with text, I can throw away, or whatever it may be. And so I think people will observe that and say, oh, this system can do a whole bunch. But when you actually look under the hood, you say, oh, well, that's 655 different models that were trained on, 4 petabytes of data, over 26 computers for 50 days, right? And yeah, that's great and all, but then someone comes along and says like, oh, can it cook me pasta? And it's going through its 650 modules and be like, oh, I don't know how to cook anything. Still can't do it, And so, that's what I kind of see come together, some type of Frankenstein monster metacognition system that can claim to do a whole bunch of stuff, but at the end of the day, it's just a whole bunch of different models that are not at all interrelated other than some common pipeline, and hoping that you get some answer, right? It's not going to be creatively intelligent. And I mean, you want to talk about the resources to run something like that, it's going to be absurd. Right?
One of the things I think, even at the level of a graduate student in electrical and computer engineering, if you look back, the more general an algorithm is, the worse it works. And as you get to more and more specific algorithms, in other words, incorporate what we call domain expertise into that, you get better and better results. And what Justin told me is looking at Kaggle and stuff, these people, especially in the contests, are doing more and more pre-processing. They're doing more and more intelligence into the solution of the problem, as opposed to looking for this one gestalt program that does everything without all of this. So we're getting more and more specific and not getting more and more general, which is what AGI purports to do. Did I get that right, Justin, you think?
Yeah, no, that's my gut feel. I know there's proponents out there that say, no, we're getting closer, and we have systems that can do stuff that we didn't really anticipate or imagine that they could, which we can question that to some degree, right? But
okay.
To me, the real benefit, especially when you look at it from an industry perspective or a business perspective, the real benefit is going to be how specific and how high performing can you get it, right? Not how general can it be. It's going to be, hey, I have to solve problem X. Get me the best solution to solve problem X.
Yeah, you're not going to be able to go to a general Oracle and do that. Well, our time is up. Thank you, Justin. Let's give Dr. Bowie, we can't applaud him. Let's give him all.
You guys don't have to applaud.
No, we're going to give you simultaneous fist bumps.
Thank
Okay?
you. Well, thank you all for
fist bumps.
For your patience and your attendance. Hopefully, at least you all learned something new. If you have questions, you're more than welcome to reach out to me. My Baylor email is fine. I'll send it in the chat here real quick. I'm happy to answer anything that I can. I can help out. Yeah. So, but thanks again for your time.
I think we have a gradient of expertise here in some of the material that you talked about. I mean, we have like computer science majors like Colin that, have their degrees in computer science, and plus other people that have onset, and then novices. I must admit that I learned a lot, 80-90% of what you told me here was something new for me. So I think
Good.
It's those people that might need help. So,
well, yeah, you all are more than welcome to reach out, and I'll get back to you as soon as I can. But yeah, there's a lot of stuff out there, so don't be afraid to go down the rabbit hole. Just keep in mind you can go pretty far and very easily, and then lose an evening or two.
That's true. That's always true. You get frustrated at some point. Okay. Thank you, Dr. Bowie. And until next time, everybody, which is next Tuesday. By the way, we're going to go over tic-tac-toe on Tuesday. I asked them, Justin, to figure out active information for tic-tac-toe. Okay.
Nice.
Yeah. So we'll see. Okay. Bye-bye.
All right. Thanks, everyone.